Hi, I'm Brent from MicroDynamics, and this is our 3D QC Veritas Analog and Reviewer Inspection System. The system's designed to be accurate, reliable, extremely easy to use, and fast, making it the ideal system for measuring analog and reviewer surfaces for both suppliers and printers. The system's portable and lightweight, connected by cable to a computer, and to take measurements, all we'll need to do is place the system on the cylinder to be measured using its V-groove base. And once it's placed there, we'll move into the software to look at how we can take measurements.
The foundation for our MicroScan 3 software is the database. If you're a printer, you have a record of every cylinder in your printing inventory. If you're a manufacturer, you'll have a list of every cylinder that you've manufactured, be it analog, gravure, or other cylinder types. This is viewing the database in manufacturer mode, which shows us cylinder work order number, manufacture date, serial number, and other information about the specifications for each roll. If we select one of these, for example, a validation engraving that we check from time to time, this bottom cylinder, you'll see the information for that cylinder, the specifications, the line screen volume and engraving angle, and then the last average measurement, which is an average of multiple scans. And you'll see in this scan database for that cylinder, the scans are arranged by group number and scan number. So in this case, we've got group number 1 has 20 individual measurements taken here, and you can see the individual measurement volumes, wall widths, cell depths. These are all scans taken in the same place on the engraving, in this case, to show the repeatability of the microscope. And then we have another set of scans that are taken all in different places around the engraving, which in this case, our goal is to try to understand the characteristic average parameters for that particular engraving. If we want to look at these as groups, which is mostly what we're concerned with, is seeing average measurement data, we can click on the Show Groups tab, and we see 4 groups of measurements that we've taken. These were all done on the same day with 2 different measurement devices, and we see the 2 that were repeatability tests, and then these that were results of measurements that were all taken in different places, and we can see the consistency from device to device on this particular engraving. So again, if we expand back into Show Groups and look, for example, at group number 3, we can select any one of these individual measurements, double click on it, and we can see detailed information about that particular scan. And we can also look at the 3D visualization for that particular measurement. Knowing this is for an individual scan, if we look at the visualization or the scan data for a different scan, we can see any unique features of that particular spot on the surface. Overall, as we watch these cylinders over time or as we validate them, we're primarily concerned with looking at group averages to understand characteristics about the cylinder. If we want to add new measurements for a cylinder, all we have to do is select the cylinder that we're looking at and click on Scans New. It'll ask us if that's the correct cylinder. We can say yes. Focus down to the surface, which takes just a couple of seconds to travel a few millimeters down until the surface comes into focus. Once the engraving surface comes into focus, we can fine-tune the focus point. And here you see the interference fringes that are characteristic with the technique we're using, which is white light interferometry. And those interference fringes are giving us depth information about the surface. We'll set them to the top of the engraving. Click on the button for Set Top. The scan range is automatically set based on previous measurements that we've taken on the cylinder, so we don't have to do anything there. It tells us our magnification setting, which we just simply confirm, and then we can choose how many measurements we want to take. So in this case, maybe let's take 3 measurements. We'll do them in the same spot to check the repeatability of the system in this spot. Click the Scan button, and we'll watch the images be captured from top to bottom. This only takes a few seconds. Already the image capture is done. It'll build the surface into a 3D surface, and there's our measurement result. Volume, depth, opening, all the automatic measured parameters. We can see the key points found, which is identifying cell centers, and that's how the geometries, the screen count, and angle are measured here. We can measure distances, angles, and estimated parameters off of the 2D image, but we can also look at, of course, the 3D measured surface, which is our ultimate goal. To see the 3D measured surface, we can zoom, move around, look at feature details of the surface, and then again use the automated measurements, which are going to be saved as soon as we click the Save Scan button. We click the Next Scan button, set the top again and scan, and so we'll let it go again. The purpose of taking multiple measurements in the same spot will only be to validate the repeatability of the microscope system. You can see here very, very similar parameters on the measurements within 1% from scan to scan is what's typical. We click Save, Next, and scan again. And so we can see we're measuring 3 times within a matter of just 30 seconds or so. In normal practice, when we're measuring and engraving, we'll take a measurement, move to another spot, and take more measurements around the engraving area and all around the cylinder to get a good characteristic average of the parameters. So there with our 3 scans, if we go back to the database and reselect the role, we see a new group of scans with 5 measurements, 3 measurements, group number 5, and we can see our average measured volume there of 7.31 for those scans taken in the same position. Another goal of ours is going to be generally to look at measurement history. So if we're a printer, we're looking at these cylinders over time as they may wear out. So we have an example roll here that we can look at under cylinders history. And this shows us the history of this engraving over time with all the measurements we've taken. So we see a green line at the specification, which is at 4.2 cubic centimeters per square meter. And we see all the measurements we've taken over time as this wears out down to a current volume of 3.29 cubic centimeters per square meter, which is a 21.6% reduction from the spec value. At this point, it crosses our 20% wear threshold, and this is a way for operator to identify this cylinder needs to be shipped out for re-engraving. So each time we take a group of measurements, we can look at the cylinder history, come to this page, and see for this particular cylinder trends of volume, depth, and cell opening decreasing over time, and the wall width getting wider over time, which indicates cylinder wear. Back to the database, we have a few more features for cylinders. We can generate PDF reports that we can send that contain all the 3D information and measurement data. We can export cylinders, so as a manufacturer, we can send this electronic data to our customer. If you're a printer, you can import a cylinder from your manufacturer, which will include their measurement data and all of the specifications. If we want to create a new cylinder, all we have to do is click on New Cylinders. We can input the cylinder ID or serial number, the type of cylinder, all the specifications about the engraving and the date, and then specifications about the engraving type. So we've got different engraving types here. We also have different cylinder types that can be used to specify what type of engraving surface we're measuring.